Welcome back to another one of my episodes on learning derivatives. This lesson will be focusing on deriving inverse functions using the chain rule, Lagrange's notation. Here is the chain rule, Lagrange's way, and it consists of you have a function within a function. So you have the blue function within the red function, and when you derive that, you get the derivative of the red function while the blue function stays the same, and then you multiply by the derivative of the blue function. And I've finally got colors, so hopefully it makes it a bit easier. Okay, so I'm going to start with our first example, that being hx equals arc cos x squared. Now keep in mind that arc cos equals cos power of -1 x squared. These are the same things, they're just written differently. Sometimes people like to have them written certain ways, but these equal the exact same. Anyway, so we know that what we've got, and what we should have if we're finding the chain rule, is we should have an outside function followed by an inside function. Okay, now we'll divide up the page for some separate working, but we're going to need a gx and an f of gx. Okay, now if I write out the derivative following the chain rule, we get, this is going to take a bit, derivative of outside function, which while the inside function stays the same, multiply that by the derivative of the outside function. So I'm a bit messy, I just got these new pens. Anyway, so that's what we're going to do. We need the derivative of gx and we need the derivative of f of gx, okay? So we're going to say that, I'll write this up, derivative gx, and we're going to need the derivative of f of gx, okay? So gx, we're going to call that's the inside function. Here's the function. The inside function in this function is x squared. Okay? The derivative of x squared is 2x. F of gx, now that's going to be arc cos gx. Why is that gx? Well, because we substituted gx for the inner function. We said that x squared was gx. That means that where x squared was is now gx. Okay? Now the derivative, okay, so the derivative of arc cos of gx is -1 over square root of 1 minus gx squared. Okay, that's what it is. That's the derivative of arc cos, or the inverse of cosine, is -1 over square root of 1 minus the variable squared. In this case, the variable is gx, so we substituted gx. Okay, now we've got what we need, this and this, so we're going to fill in this. Okay, so what do we need? We need the derivative of f, leaving gx alone. That's this one down the bottom. -1 over square root of 1 minus gx squared multiplied by derivative of gx. The derivative of gx is 2x. Therefore, we'll have negative 2x on the top over 1 minus, I'm going to sub in gx. We said that gx was x squared, so I'm going to put x squared in instead where the gx is, because it equals the same thing. And we got to remember the square, because there's still a squared on the outside. Gx squared, x squared, which is then squared again. Okay? So that's the derivative. I'm going to simplify this by simplifying this little bit down here. This 2x is still going to stay the same, all over the square root. 1 minus still stays the same, but it's going to be x to the power of 4. And that is our derivative of arc cosine x squared. It's down the bottom here. It's just down here. Okay. Now I'm going to do another example, hopefully to make it stick a bit better. So here we've got example 2. hx equals 10, negative 1, e to the x. Okay. We know that we're going to need the outside function and the inside function. Okay, because the derivative of hx is, I'll just put the multipliers there, the derivative of the outside function, while the inside function stays the same, multiplied by the derivative of the inside function. Okay, so we have an outside function and an inside function. Here we have an outside function and an inside function. What's the inside function? Ex. So we'll label gx as being equal to ex. Therefore, f of gx will equal 10, or the inverse of 10, gx. Okay? Because we've subbed in gx for ex. Ex was here, now it's gx. Or e to the power of x, I should say. But now we've got to find the derivative of gx. And we have to find the derivative of f with respect to gx. Okay? So let's start with up here. Derivative of gx. Derivative of e to the power of x is e to the power of x. If you watch my other videos, you would know that. Or if just by common knowledge. But anyway, the derivative of the outside function, while leaving the inside function the same. The derivative of tan, an inverse of tangent, is 1 over 1 plus gx squared. That is the derivative of this up here. Okay? Now, we've got the derivative of f with respect to gx and the derivative of gx. That's all we need to complete this. So now what we're going to do is fill it in. The derivative of f with respect to gx is 1 over 1 plus gx squared multiplied by the derivative of gx, which is e to the power of x. Therefore, bring e to the power of x on top. 1 plus, I'm going to sub in gx. We said that gx was e to the x. That's what we're going to get. Okay? Now, I'm going to simplify this. We're going to have e to the power of x over 1 plus e to the power of 2x. Because e to the power of x squared is e to x. Okay, that here is the derivative of the inverse tangent of e to the power of x. I hope you learnt something, and thanks for watching, and have a good day.